French fries look simple. They're thin, they're golden, they're crispy on the outside and soft on the inside. But behind every single fry is a massive industrial process designed to turn millions of raw potatoes into identical, restaurant-ready perfection. And it all starts long before the potato even reaches the factory floor. Choosing the right potato. Not all potatoes are created equal. Factories don't just grab whatever potato is available. They rely on specific varieties, most commonly Russet Burbank or Shepody potatoes. These potatoes are chosen for three critical reasons: high starch content, low moisture, and consistent size. High starch gives fries that fluffy interior. Low moisture helps them crisp up properly. And consistent size ensures even cutting and cooking later on. Farmers grow these potatoes under tightly controlled conditions. Soil quality, irrigation, and harvest timing all matter. If the sugar level inside the potato is too high, the fries will burn during frying. If it's too low, they won't brown properly. Once harvested, potatoes are stored in climate-controlled warehouses. Temperature and humidity are carefully regulated so the potatoes don't sprout or convert starch into sugar. Only when the factory is ready do these potatoes begin their journey. Arrival at the factory. When the trucks arrive, they don't unload gently. Potatoes are dumped into large receiving bins, sometimes by the ton. At this stage, the factory doesn't care about appearance. Dirt, small rocks, and broken potatoes all come in together. This is where industrial efficiency takes over. The potatoes move onto massive conveyor belts and into water flumes. These flowing channels of water do two things at once. They transport the potatoes forward, and they begin washing away dirt and debris. Water is the safest way to move potatoes without bruising them. Bruising would lead to dark spots in the final fry, and that's unacceptable in large-scale production. Washing and sorting. From the flumes, the potatoes enter high-pressure washing systems. Powerful jets of water blast off remaining soil. Rotating drums tumble the potatoes gently, ensuring every surface is cleaned. Next comes sorting. Modern factories use optical scanners and laser sensors. These machines analyze each potato in milliseconds. They check size, shape, and surface defects. Any potato that's too small, too damaged, or discolored is automatically removed. Nothing is wasted. Rejected potatoes often go to animal feed, starch production, or other food processing streams. Only the best potatoes move forward. Peeling the potatoes. Now comes one of the most satisfying parts of the process: peeling. In most factories, potatoes are peeled using steam peeling. The potatoes are exposed to high-pressure steam for a few seconds. This causes the skin to loosen instantly. When the pressure is released, the skins literally burst away from the potato. No knives, no chemicals, just physics. After steaming, the potatoes pass through rotating brushes that remove any remaining skin. A final rinse washes everything clean. At this point, the potatoes are smooth, pale, and ready for transformation. Precision cutting. This is where fries are born. The peeled potatoes are fed into high-speed cutters. Each potato is pushed through a grid of razor-sharp stainless steel blades. In a fraction of a second, one potato becomes dozens of perfectly shaped sticks. The size of the grid determines the fry style. Thin for shoestring fries, thicker for steak fries, custom shapes for specific brands. Speed is everything. Some cutters process thousands of potatoes per minute, producing an endless waterfall of raw fries. The freshly cut fries immediately fall into cold water. This prevents oxidation, which would turn them brown, and washes off excess surface starch that could cause clumping later. Quality control at every step. At this stage, the fries may look ready, but the factory isn't done checking them. Cameras inspect the fries for length, thickness, and color. Broken pieces are filtered out. Some factories even use artificial intelligence to spot irregularities faster than the human eye. Why all this effort? Because consistency is the secret behind why fries taste the same, whether you're in New York, Tokyo, or Paris. Quick reminder before we dive back in. If you enjoy behind-the-scenes factory processes like this, make sure you're subscribed, hit like, and share this video with someone who loves French fries just as much as you do. Now let's turn up the heat. At this point in the factory, the potatoes no longer look like potatoes. They look like fries. But raw fries are fragile, they're pale, they're soft, and they're nowhere near ready to be eaten. What happens next is the most critical stage in the entire process. This is where flavor, texture, and color are engineered on purpose. purpose. Blanching, the first heat treatment. The freshly cut fries are carried by conveyor belts into massive blanching tanks filled with hot water. This step is called blanching, and it serves several important purposes. First, it removes excess sugars from the surface of the fries. Remember, too much sugar causes fries to burn too quickly when fried. Blanching solves that problem. Second, it partially cooks the fries. This softens the interior and begins setting the final texture. Third, blanching deactivates enzymes that could cause discoloration or off flavors later. The water temperature is carefully controlled, usually between 160 and 180 degrees Fahrenheit. Too hot and the fries cook too much. Too cool and the sugars won't be removed effectively. Timing matters too. Fries may spend anywhere from 3 to 15 minutes in the blancher, depending on thickness and potato variety. When they emerge, they're no longer raw, but they're not fries yet. Drying, removing surface moisture. After blanching, the fries are soaked with water, and water is the enemy of crispiness. So the next step is drying. The fries pass through powerful air dryers that blow hot air across their surfaces. Some factories use vibrating conveyors combined with air knives, thin, high-speed streams of air that strip moisture away instantly. This step ensures the fries won't splatter violently when they hit hot oil later. It also helps oil adhere evenly during frying, which improves both texture and flavor. Every second here is calculated. Too dry and the fries won't cook properly. Too wet and they'll absorb too much oil. Optional coating, the secret to extra crispiness. Here's something most people don't realize. Many frozen fries are lightly coated. This coating is usually a thin layer of starch, sometimes mixed with seasoning or a small amount of sugar. The purpose isn't flavor, it's texture. That thin coating helps fries stay crispy longer after cooking. It also gives them that signature crunch you hear when you bite into a restaurant-style fry. Not all fries are coated. Some brands skip this step entirely, but when it's used, the coating is applied evenly using rotating drums or spray systems. Once coated, the fries move immediately to the most dramatic stage of all, par frying. Locking in flavor, now comes the oil. The fries are lowered into massive industrial fryers filled with vegetable oil, usually canola, sunflower, or a blend designed for high heat stability. This is called par frying, not full frying. The oil temperature typically sits between 340 and 380 degrees Fahrenheit. The fries remain in the oil for less than a minute, sometimes only 30 to 90 seconds. In that short time, several things happen. The outside of the fry forms a thin crust. Moisture inside turns to steam, creating tiny air pockets. The structure of the fry is permanently set. This is the moment when a fry becomes a fry. Color is carefully monitored. Optical sensors watch for exact shades of pale gold. If the fries darken too quickly, the line is adjusted immediately. Factories aim for a light golden color because the final browning will happen later when the consumer cooks them. Oil management and safety. You might be wondering, how do factories keep oil clean when they're frying non-stop? The answer is constant. Filtration. Crumbs, broken pieces, and starch particles are continuously removed from the oil using fine mesh filters and centrifuge systems. Fresh oil is added regularly to maintain quality. Temperature, oxygen exposure, and oil age are monitored by sensors around the clock. If oil quality drops, the system alerts operators instantly. This isn't just about taste, it's about safety and consistency at an industrial scale. Cooling the fries. Once par frying is complete, the fries exit the oil and move on to cooling conveyors. Cold air is blown across them to stop the cooking process. This step stabilizes the structure and prevents sogginess. At this point, the fries look almost ready to eat, but they're still not finished. They need to survive freezing, shipping, storage, and final cooking in your oven or fryer. And that requires one last transformation. Inspection before freezing. Before freezing, fries pass through another inspection stage. High-speed cameras scan every fry for color, shape, and defects. Metal detectors ensure no foreign objects made it into the product. Weight sensors confirm portion accuracy. Any fry that doesn't meet standards is removed automatically. This level of control is why frozen fries cook evenly at home. It's not luck, it's engineering. And now, the fries are ready for the cold. Before we jump into the final stage, make sure you've liked this video, subscribe to the channel, and drop a comment telling us how you like your fries, crispy, loaded, or straight out of the fryer. Now, let's follow these fries all the way to your plate. At this stage, the fries are par-fried, cooled, and perfectly shaped, but they're still warm, and warmth is the enemy of long-term storage. To survive months in freezers and still taste fresh, fries must be frozen in a very specific way. Flash freezing, stopping time. The fries enter massive industrial freezing tunnels. Inside these tunnels, temperatures plunge to as low as -40 degrees Fahrenheit. Powerful fans blast icy air at high speed, freezing the fries in just a few minutes. This process is called IQSF, or individually quick frozen. Freezing the fries rapidly prevents large ice crystals from forming. Large crystals would damage the internal structure, leading to soggy fries when cooked later. Instead, rapid freezing locks everything in place: the texture, the flavor, the shape. Each fry freezes individually, which is why frozen fries don't clump together in the bag. Final quality and checks. After freezing, fries pass through one last inspection. Sensors verify temperature. Cameras check color consistency. Scales confirm exact weight. Some factories even test random samples by cooking them on site. These fries are fried or baked just like they would be in a restaurant. Operators evaluate crispiness, color, and taste. If something isn't perfect, the entire line can be adjusted immediately, because at this scale, a tiny mistake affects millions of servings. Packaging, speed, and precision. Now it's time to package. Frozen fries move at high speed into automated packaging machines. Bags are filled, weighed, and sealed in seconds. Air is removed to prevent freezer burn, and some packages are flushed with nitrogen to preserve freshness. Every bag is printed with batch codes, production dates, and cooking instructions. These codes allow full traceability from factory to farm. Large food service orders are packed into bulk boxes. Retail fries are packed into branded bags you recognize from the freezer aisle. All of this happens fast in cold rooms to keep the fries frozen solid. Cold storage and distribution. Once packaged, the fries are transferred to massive cold storage warehouses. Temperatures stay well below freezing, 24 hours a day. From here, the fries begin their global journey. Refrigerated trucks transport them to distribution centers. Cargo ships carry them across oceans. Cold chain logistics ensure they never thaw along the way. Whether they end up in a fast food kitchen, a restaurant freezer, or your home, the goal is the same. Keep the fries exactly as they left the factory. Why fries cook so perfectly at home? Here's the genius part. The fries you buy are designed to be cooked twice. They were par-fried at the factory. They were frozen at peak condition. And now, the final cooking happens in your kitchen. When you bake or fry them, moisture inside turns to steam again. The preformed crust crisps up, the interior softens, and the fry reaches its final golden color. That's why frozen fries cook evenly. That's why they're crispy on the outside and fluffy inside. That's why they taste familiar every single time. It's not just cooking, it's controlled repetition from farm to fry. Think about the journey. A potato grown in a field, stored carefully for months, washed, peeled, cut, blanched, dried, coated, fried, frozen, packaged, shipped, and cooked again, all for one bite. This entire process exists to deliver something simple, fast, and comforting: a French fry. And the next time you hear that crunch, you'll know exactly how much science, engineering, and precision went into it.